point agenda, which I guess at the moment is only in the Slack channel. But essentially, we've got two presentations from two of the BioC core team. Hopefully, we'll have plenty of discussion about things as well. So we will have Hervé, is Hervé here? We might change the order. But Hervé is presenting about the changes he's making to the DataFrame package, which in his words were how he's going to break everybody's package 2 days before release. So we can all look forward to that. And also Laurie is presenting about serialization of objects, and I guess what can go wrong with that, and maybe some suggestions for how we should be dealing with those kinds of things. But before we pass over, I guess we'll give everybody a couple more minutes. I just wanted to say thanks for coming back. Looks like we've got a decent turnout again this month, which is good to see. And also thanks to people who have been contributing to the single cell analysis book, which, if nothing else came out of last month's, it seems like there's been a ton of work done into that. I don't know if new people have been contributing. Maybe Aaron can say whether that's the case or not, but it looks at least like tons of work has been going on in that channel, which came out of last week's discussion. So that's really cool to see. Yeah, so does anybody know if Hervé is on his way or signed in, what time zone he's in?
He's at the hutch, right?
Yes. I wasn't actually sure whether he was serious about his contribution there, but it's the West Coast now, 9 in the morning, but he usually gets up pretty late, I think. So we should probably do Laurie's stuff first. Yeah,
cool. I've definitely heard from Hervé that this time suited him. He was fine with it, so I'm sure he'll make an appearance at some point. But if not, then Laurie, we can bump you up the order. Feel free to take it away.
Guess it would help if I unmuted myself then, huh? See. Just trying to share my screen here.
Should be one of the top buttons, right, next to the mic.
Yeah, I normally don't sign on from my home computer, so it actually didn't have the Chrome extension that I could there. Can everyone see that?
Yep.
Okay. So
yeah, looks good to me.
basically, Martin and I kind of wanted to address the topic of data and how data is contributed to Bioconductor with regards to serialization of objects and what kind of best practices we should be doing. And it's also hopefully going to be an open discussion at the end. But to get the discussion rolling, just kind of the idea that we're talking about is that at some point, from a personal point of view, maybe you're working through some sort of workflow and you save some intermediate object for reproducibility, or maybe you want to try a couple different workflows and you save some sort of intermediate that then you can revert back to or try different things on. And then from a package perspective, we're talking about data for vignettes and examples and reproducibility there. Maybe it's reference data, maybe it's annotation data, but that has some sort of package-specific data relation. And then where we include this data can also be somewhat up for discussion. In general, we think that like if they're very small data resources, that they could be included within the package itself, in a data directory or that TXT data directory. And if it's like 1 to 100 megabytes, that maybe it's distributed through maybe the hubs or some sort of resource like that. And possibly if it's greater than that, maybe it's not the best medium for Bioconductor to distribute, but that can be up for debate and maybe improved upon. the way that data can be stored is kind of where we're really getting into the thick of things and want a little bit more of a discussion on too, where we have this idea of different R formats, which I think is what we're kind of considering like the serialization, where it has some sort of defined structure or a class structure to it. And that can be an S3 or an S4 object. And the pros of using this type of format is that they're fast, they're easy to load, they're already pre-constructed, but they would be only useful in R. And then using like a defined class, especially like an S4 method, if you make updates to that class structure and have already saved an object in the old class structure, there needs to be some sort of update method for older class objects, and if that's not made, you're kind of stuck with this broken object. Then there's, of course, more like community standard formats or like raw formats or native formats, however you want to think of it, where maybe they're like a CSV or a bed file that can be more consistent, useful outside of R and a lot of other different applications or programs. But the cost of that, when we're talking about it in our community, is that coming from a raw file can be very time consuming to import or construct the more useful R format. When we talk about those serialized objects, there's also ways to unserialize and how to serialize. So there's read RDS, where you would save like a .rds file, which is somewhat better than data and load, because if it's an S4 class, it would attach the necessary packages that would be needed for that class structure, but there is no automatic validation or updating of these objects. So it would read the object in, but again, if that class structure is changed, there could be some issues there. And that's where there's this update object, which may not be as well known to people, but there's a BioC generics update object generic where you can create these methods for updating from one version of an object to another. And so that leads into, again, the bigger discussion of what do we want as our best practices in Bioconductor? What should we be recommending to people? And where do people stand on their opinion of both where should this data be hosted and the pros and cons of that, as well as how they should be hosted, if it should be more of those community standard formats, or is that too expensive, or should they be in serialized objects, and what the preference should be. And then our standard acknowledgements of our funding and our Bioconductor core team, as well as standard acknowledgements. And with that, I'll kind of open it up to discussion. Anyone wants to chime in on what they think the best practices should be?
Yes, I do.
Or any comments?
So I guess from two perspectives. I mean, the first perspective is that from a user perspective, it is only barely tolerable that some of my single-cell RNA-seq packages take so long to take as long as they do to load, and that's already when they're serialized in RDS files. So there's definitely a consideration for sort of how quick you can load these objects into memory, which sort of argues for using RDS files. And I can see how it's I can see how, why we want to have to use community standard formats. But I guess I would say that it sort of depends on what you envisage the experiment hub to be. Because if we're just using experiment hub to load for use within to use for retrieval into R sessions, then there's not so much of a need to be tied to a particular standard format.
Fair enough. Anyone want to second that or have a refuting opinion? Or
I guess one of the things we've been talking about ever since getting involved in the Chan Zuckerberg things is trying to make basically the Python world of single cell analysis interact with the Bioconductor world of single cell. And I don't think that's been particularly well achieved. So maybe by having some standardization or a form, I mean, does anybody know how an RDS file is actually written? As in, I've looked up what's the definition of the format, and it basically everything I find just says read the source code, which it doesn't seem like a particularly well maintained or sort of responsible attitude to it. But I mean, it does seem to work, but I wonder whether there is an argument to be made that you almost define your own thing with a better definition for particular data structures that we could actually then share with other languages.
I don't know whether Mike mentioned this, but he was talking to Gabe Becker about allowing sort of auto updates from RDS files, and allowing extraction, if I remember correctly, allowing random access from within RDS files to retrieve particular components of objects. And I imagine that would also be an opportunity to nail down what the RDS file actually is. But that might be one of the to-do items if they're making that many changes.
Yeah, I guess there's also a balance between something generic, right? An RDS file basically can store anything in R, right? And then something that's very specific for a particular class that we define in Bioconductor that represents just one type of experiment or type of data or something, right? And that, I guess, leads to fragmentation. Maybe it's also helpful. I don't know.
And question I have is that is linked to this issue with, if you have large data, it takes a lot of time to read into memory, and sometimes it fit in memory. So one solution for that would be to have a lightweight S4 object and then delegating accessing the data on disk. But in that very specific situation, how can I address the serialization, right? Because even I serialize my 4 object, the data, as far as I know, I don't think the data is somehow magically copied into that RDS file, right? So I would still have to distribute my RDS file and maybe that external resource, QL, HDF5 or whatever it is, and make sure that wherever these are copied, or make sure that they are kind of have the relative matching, that the relative path between one and the other still matches. So that suddenly complicates the thing extremely. So I was wondering if anyone had ever considered that or has some suggestions.
So the 10x PBMC data sets and the 10x brain data sets have this same problem because they basically distribute HDF5 matrix objects that are basically where the data is held in a HDF5 file, and for those we get around it by distributing the file, but on the user side they have to there's a function that reconstructs the object for them, right? So that makes sure that the file paths are set properly and everything like that. But for sure, if you saved and if you serialized the stub, the sort of lightweight S4 object, it would be, and you wanted to distribute that, then it would be the user's responsibility to have to reset the internal paths, which is just painful.
So you distribute the HDF5 file?
Yeah, that's right.
With the data. And what about the metadata that is not necessarily, I don't know, that is some sort of summary statistics, summary metadata?
Right.
How would you distribute that? Would you add that to the HDF5 too, or?
I don't remember exactly how we did it for that particular data set, but if I remember correctly, that was distributed as a separate data frame in an RDS file, right? So we had, I mean, you can put it in the HDF5 file. It's not a big deal, but in this case, it was just easier to put it. Like, it was just not just to separate it out. So yeah, in that case, I think we distributed 3 files: the HDF5 file containing the data, a data frame containing the row data, and a data frame containing the col data. So all 3 of these files would land into onto the user's disk, and then the 10x brain data function. So there's actually a function named after the package that would construct a single cell experiment object from those 3 components.
Okay. And would it be possible to have the S4 object that contains the col data, the raw data, right, that are generally relatively small, and then in that S4 object point to a experiment hub resource? So the user would easily unserialize the S4 object and have everything ready. And once they want to access the raw data, then, I mean, that path or that resource would be set and available remotely. Would something like that be feasible? To try to keep the best of both worlds.
So if you had a sort of like experiment hub matrix class that points to a remote resource or something like that.
Mm-hmm. Well, you know, that HDF5 would be local, but it would be somewhere else. And everybody would then access that somewhere else if they want to manipulate that S4. So the S4 part would be local, but the large data would be remote.
So I think Vince has this RESTful matrix class. I don't know if he's here. Which should do something similar to that. I got the impression that wasn't very performant, though someone else might know more than I do about this.
So I don't know anything about how performant that is, but maybe you could have something similar that, I don't know how this would work, but can check whether you have a local copy of it, and if not, go to Experiment Hub and download it, because at the moment it puts everything in the BioC. It's probably the Experiment Hub cache, but one of the local caches, right? And so it looks there and uses that if it can do. So maybe you could have something that does the check for whether that exists. I don't know how easy it is to know the name that it will have in its local cache form and that kind of thing, right? The kind of engineering, I don't really know how you would go about it, but maybe you could have something like this, right? So instead of accessing it remotely, you still download it if you need it. But the kind of pointer when you save it is to get one or the other, rather than always looking on local disk. Because what you've said actually has happened in people like making vignettes and things, right? They don't realize that if they subset the data and save it as an RDA file and distribute it with their package, all that happens is they get a pointer to a local file on their own hard disk that doesn't work for anybody else. And there have definitely been a couple of examples of people doing exactly that because they had no idea that they really needed to also build something that reconstructed it or have the subsetting operation done in their vignette, right? They just did the kind of traditional, I'm going to make a small sample and save that somewhere. And that isn't really appropriate for this kind of approach. So if nothing else, we need to explain to people better that that's when they're using, for instance, the 10x brain data set and things, that they can't just save it in the way they would with other data sets.
I was going to say 2 things. One was that the BioC file cache, which Experiment Hub and Annotation Hub are built on, kind of serves this purpose of if the data is local, use it, otherwise go and get it and save it somewhere in a consistent fashion. So in many ways, as developers, we don't have to reinvent that kind of wheel. So it's kind of already the logic and it's already implemented either in Experiment Hub for mature resources or through BioC file cache for sort of more transient types of things. And I also wanted to say that in general, it seems like the cost of creating an S4 object in the grand scheme of things isn't really that much. So it seems like it's much better to save the components in as simple a format as possible. I was kind of going after or thinking about what Laurent was talking about. Saving the components in as simple a form as possible, and then constructing the object on the fly, as opposed to trying to store the container separately from the data that it contains. Like the container itself isn't generally expensive to construct.
Yeah, I agree with that. I think all of the resources in the single cell RNA-seq and the scRNA-seq packages construct the single cell experiment on the user side. But we do try to serialize the count matrices directly, because those actually do take quite a while to read in from text form. So, for example, you will commonly see, for example, people densifying sparse matrices and then saving them as a count table in a TSV file, and that can take a minute to read in, whereas it takes like seconds for when you read RDS on a serialized DGC matrix object. So that's the compromise we made.
It might be good to think about that like compromise of doing, like you said, the minimal when possible, and then if there's something that does take a while. And I think that's where, I know she said she couldn't make this meeting, but I know Stephanie was looking into something like that and was doing work on the hub, and then found to construct from the raw files just took way too long. And so then we went back to, okay, well, should we be storing in a serialized form in this case, since it would be not possible in that case? Or possible, but really inconvenient for users.
Mm-hmm. Yeah, I also experimented with, for some of these packages, I was like, I don't want to have to every time put something onto Experiment Hub. So I thought, you know what I'll do? I'll just pull it out of GEO and construct the object on the fly. And that just took so long. It was just I was trying to use these things in examples, and all my examples were hit how check warns you when your examples run over the clock. I mean, all of them were running over the clock, right, because of this. And I was like, well, I'm not doing that.
Where was the bottleneck there? Like Geo's connection, or the volume of data, or like having processed data is actually more beneficial here, or something?
Yeah, it was just parsing the file, parsing this dense matrix that people always insist on giving you, and then reading that in and then converting it into a sparse format. That was a real pain. And I mean, it doesn't stop there, right? Because if you're lucky, you get a dense matrix that you can read in with read table or whatever. But actually, what usually happens is that they put metadata into both, they put row metadata and column metadata into the same file, right? And then you have to, not only do you have to read it, you have to also unpack the metadata on both dimensions, and then finally coerce everything into a numeric matrix. So that's where the fun really starts. I mean, you can have a look at some of the scripts in scRNA-seq, because they get pretty crazy. I mean, but in some respects, that's a bit of an unfair comparison, because if we were going to do a standard format, then, I mean, for example, for sparse matrices, I would convert them to the MTX format, and then we'd put that onto Experiment Hub, and all the metadata tables would just be text, like TSV files, and we could put that onto Experiment Hub, and then that would be fairly easy to read in. Not as fast as RDS, but still pretty faster than what we have now. Maybe we should do that.
So MTX is a text-based matrix format, right?
Yeah.
Standard text-based matrix format.
Hi. Can you hear me?
Yep.
Based on Martin's message on the chat here, I guess that if you upload flat files or text files, it could be possible to make some type of Python package or something that can query Experiment Hub and get you the paths to the files. Because that would be the motivation of doing this, right? Like make it easier for people from other languages to access the data. So does that sound reasonable?
Oh crap. Yeah, if we had text, if everything was in standard form, then I mean that shouldn't be too hard. I mean, so the broader question of integration with Python, for me, wasn't so much about the data, even though that's sort of important, but it wasn't so much about the data as it was about the sort of, at least not for the raw data, like for the starting point of the analysis. It was more like, if I wanted to call a Python method on my data in an R session, could I do that easily from within R? I thought that was the impression that I got about the interoperability of the different methods. Because if you think about it, at least in the context of the Human Cell Atlas, that's not so much of a problem for them because they're always providing it in a standard format, whether it be TSV or HDF5 files. So the raw data from the HCA's perspective is already interoperable. It's more about the methods. Well, I thought I got the impression it was more about having the methods and the packages and the downstream infrastructure being more interoperable.
So I was wondering
does anybody have a feeling that's true, right? Like, if you start an analysis in R, can you at any point swap to use a Python program and then swap back again later, or do you have to jump through some hoops to save the data out in a different format, even if it's just transposed or something, because we do different things? Like, I've never tried doing this, but I'd be interested to know if anybody has.
I mean, in principle, it's easy, right? Reticulate works pretty well. The real problem is getting a consistent installation of Python. I mean, that's the thing that I've always struggled with, and getting stuff installed in the right location and getting Python paths to find it, the stuff like that.
One of the other things.
Sorry, Martin.
Maybe it was a different topic, but I was wondering about the update object method and whether people had written classes on the call, and then other than Hervé, whether they'd actually been conscientious about providing update object methods to allow for people to keep their serialized instances current.
I have. Yes, for the single cell experiment object, we recently changed some of the internals. So I had to write an update object method. First time doing so, I think. So that was pretty exciting. I say that sarcastically. So the main problem for me with writing this thing was that I had no opportunity to test it, because I don't actually have any old form serialized single cell experiment objects. So I basically had to sort of guess, or do educated guesses about whether or not, basically static code analysis and just staring at the code to figure out whether it would work or not. And there's at least one case where it slipped through the cracks, and someone complained to me on BioC Devel. I guess I should have kept around some of these old objects for testing, but that's something to keep in mind.
And was your strategy, or if you've thought about it, like were you going to do the any-to-any sort of update, or were you thinking that your objects would go from, version 1 to version 2 to version 3, and you'd provide those incremental updates? And then I also wanted to ask, how do you know? You just said you didn't have any old serialized objects, but how do you know what version of object your current object is?
Yep. Second question first. So in our defense, we did have a little bit of foresight, and we did stick in the object version into the single cell experiment class. So every single cell experiment instance carries around the version of the package that was used to generate it. So that's how we know what version of the object it is. So basically, the update object sees the version of the object, like literally just sees the version of the object, and then figures out what to do from there. What was the first question? Sorry, Martin. I've forgotten what the first question was. Your
update strategy, like were you going to implement 1 to 2, 2 to 3, 3 to 4, or 1 to 2, 1 to 4, 1 to...
Yeah, they all go. The 1 to 4, 2 to 4, 3 to 4. It's simple enough that the changes are simple enough that we didn't really have to worry too much about it. In fact, actually, come to think about it, there was only a 1 to 2 because this is the first change that we've made of this magnitude. So it just goes from 1 to 2. But having said that, one of the other classes that I've been playing around with is this genomics interactions class, and there is at least 2 different prior definitions, and that will involve a 1 to 3, 2 to 3, basically, rather than 1 to 2 and 2 to 3. And in that case, that object class doesn't have a version number attached to it, but each of the changes was so dramatic that we could just have a look at whether or not particular slots were available or were even present, and then decide what to do from there.
I guess maybe one final thing about thinking about updated object types of methods is what happens when your object consists of slots that are objects themselves, and whether you I guess the idea is to localize the updates to the class itself.
Yeah, I don't. Yeah, so the update objects that I have don't touch the values of this, or generally speaking, they don't touch the values of the slots themselves unless they have to. So if there was an old object in those slots, then.
I also had such situations where I had update object methods, and I was also fortunate enough to have the class version stored as part of the object. But I think this only works for relatively mature objects, because any little change to the class definition requires changing the object, writing these update methods functions, and somehow this added complexity suggested try to keep the S4 class maybe as simple as possible. Maybe have a kind of very general slot and shove a list in there where there is much more flexibility, and maybe this requires a little bit manual checking to see, does that list have this? I'm not saying that's a good way forward, but I think that the kind of the increased complexity with every little, even a little change, changing a slot, adding a slot, had a quite big impact I think as a developer, having to write all these methods and these update object methods, checking the classes, the class versions, and then realizing or having to remember, having to look back, what were the changes in these objects over different versions. So I haven't had to do it in a long time, fortunately, but my memory is that this is not necessarily something trivial to do.
Well, this has been super interesting, but we are over halfway through. Let's hopefully there'll be more discussion in Slack or something, but let's let Hervé, who I think is here now, I think I've seen his name on the list, present about the changes he's making. Capital D, capital F data frame class. So take it away, Hervé.
Okay. You can hear me?
Mm-hmm.
Okay. I'm going to share my screen. You guys see my screen?
Oh, yep.
Okay. Good. Okay. Yeah, so I'm gonna talk about those changes I've been making to the DataFrame class. And I introduced this new DFrame class. I'm gonna talk about this. But so before I go to the DataFrame, DFrame story, I want to provide some context and talk a little bit about virtual classes and what we use them for typically, and what's the difference between a virtual class and a concrete class. So I guess most of you are familiar to the concrete classes, the regular classes. Most of the classes that are defined in most Bioconductor packages are concrete classes. What's the difference between a concrete class and a virtual class? Well, the difference is that you can instantiate a concrete class, but you cannot do that with a virtual class. If you try to call new of V, if V is a virtual class, it fails. So virtual class cannot be instantiated. Why do we need that? So, so typically this is the situation here where you would use a virtual class. So this is a situation where you have an abstract object in mind, a concept, let's say, but there are possibly more than one implementation for that concept. And so this is a situation where you can actually use a virtual class. And the virtual class is going to represent the concept, and below that class you can have one or more subclasses that are going to be concrete subclasses that will where each of them is going to implement the concept, but each of them is going to implement a different internal representation of that concept. So that's very that's very abstract. So now more concretely, so here is an example of a virtual class, and we have many in the core infrastructure, but character list is one of them. And so what we have is that character list is virtual, and it has two concrete subclasses: simple character list and compressed character list. A long time ago, we used to display the the full name of the class when we're displaying those objects. But we changed that at some point because that would be maybe too much information and maybe a little bit confusing for the end user. So you can actually sometimes we talk about flavors. So character list has two flavors. It can be simple character list or compressed character list, and the difference between the two is the internal representation. And internal representation, as you know, should not be something that the end user knows about or is should be concerned about, right? So it's actually good that when we create those objects, either a simple character list or compressed character list, we get something that is a character list, and that's all what matters for most of the end users, right? So in my example here, X1 is a compressed character list, X2 is a simple character list, but as you can see, the show method for those objects only say that they are character list objects. And if you want to know the real class, if you want to know the flavor of that character list object, you can call class on it, and then you see the truth. So as I said, those two flavors correspond to two different internal representations. And so I'm showing you here the slots of those classes. Lots of slots are, most of the slots are the same, actually, but with some differences though. So simple character list has this list data slot, which is an ordinary list, but compressed character list doesn't have that slot. For compressed character list, this slot has been replaced by an unlist data slot. That could be anything. Yeah, maybe I should change the class definition for that. The unlist data slot is a place where we actually store the unlisted version of the object, right? So the character list, the list of character vectors has been flattened out and stored in this flattened form in the unlist data slot. And then we keep track of the original grouping of the data in this partitioning slot. So unlist data should actually be character. So DataFrame-like containers. So now back to DataFrame. So we have the DataFrame class in S4 Vectors. Was implemented by Michael many years ago. You use DataFrame objects all the time. That's what the metadata columns of any vector derivative should be like, right? They should be stored in a DataFrame, capital D DataFrame object. Same for summarized experiment objects and their derivative, like single cell experiment. We use DataFrame a lot there. The call data, the raw data are expected to be DataFrame objects. And for those objects, the columns are just stored in an ordinary list. So the slot that matters here is the list data slot. Same name as for the character list that we saw before. And that's it. So all the data is in memory and stored in this ordinary list. Works pretty well. And the API for DataFrame is very similar to the API for standard ordinary DataFrame, lowercase DataFrame. We have a work in progress that is the SQL DataFrame class by Jian Liu and Martin. This has not been submitted to Bioconductor yet, I think. And this is an attempt at implementing a class that will behave like a data frame, except that the data now is on disk in an SQL database. And really, what we'd like to be able to do is use those objects almost in a transparent way everywhere a data frame is expected. And the very important use case that we care about is to be able to store an SQL data frame object in the metadata columns of a vector derivative, V uppercase. When I say vector derivative, V uppercase vector. And we also want to be able to do this with the raw data or call data of experiment derivative. We like to be able to use an SQL data frame object there because the use case is when the data doesn't fit in memory. So we have it on disk in an SQL database, but we can still have this data attached to a single cell experiment object or summarized experiment object. And here's where we actually want, this is a typical situation where we can use the virtual class approach that I described earlier. So the diagram I'm showing is where we want to be in a few months from now. I don't have an exact roadmap, but that's where we want to be. We want to have data frame, not a concrete class with the least data slot, but a virtual class with no slots. And so that's our concept. And what is currently the data frame internal representation, we're going to move that implementation to a new class, DFrame, which is a concrete subclass of data frame. And once we have this, now we have room for other flavors of data frame, other internal representations. And SQL data frame could be also, a concrete subclass of data frame, and other things like Parquet data frame or anything that points to on disk data and behaves like a data frame. We want to, have we want all, of course, we want all those objects to behave like the frame. That means concretely that they should support the data frame API, things like dim and row and call and many other things. But of course, and that's the reality, right? Possibly with some restrictions. There's no way that those on-disk objects will always support all the things that a DFrame object supports, just because of the fact that the data is on disk. So, for example, maybe the data is on a remote place and you don't have write access to the data. So things like double bracket replacement won't work for some of those classes. And but the idea is that they support enough of the data frame API to be usable everywhere a data frame is expected in a transparent way. And with this as coercion to DFrame, coercing one of those objects to DFrame becomes a standard idiom for loading the data in memory. It will convert those on-disk data frame objects to an in-memory data frame object. Other benefits of this organization, the virtual class, the virtual class hierarchy that I just showed, other benefits of that is you can define some methods at the level of the virtual class itself. For example, if you have implemented nrow and ncol on your on-disk data frame derivative, then there should be no need for you to implement dim. Same for length or for dim names and other things, because it's going to be the same thing for all those data frame derivatives, right? And so we can actually define these methods at the level of the virtual class, at the level of data frame here. And this avoids a lot of code duplication across all those data frame derivatives. So this is still a work in progress. I announced some initial changes that I made to the S4 vectors package back in August, and so basically what I did was to add the DFrame class. And what happens now is that when you call the DataFrame constructor or you coerce to DataFrame, you get an object of class DFrame. However, you don't realize this immediately because those DFrame objects are displayed as being DataFrame object. And it's not a lie, they are. If you look at this from the ease perspective, right? We have ease in the methods package to that we can use to see if an object belongs or inherits from a given class. And this trick, the fact that we don't fully disclose the real name of the class of the object that we display in our show method is not new, right? As I showed before, we've already been doing this for years for character list objects and other objects like G-ranges list and like that. So with those changes, things are transparent for the end user. Nothing is different from what the end user was doing before. The user still has the impression to deal with capital D data frame objects. This change is mostly transparent for the developers, but I had to go fix a few packages that broke because of this change. Because they were using things like, class of X, W equal data frame, in their test, in their if statements, and really that's not the way you should test for, to test whether to see whether an object is of a certain class or inherits from a class. You should always use is. And so after fixing those packages that were using class of X, W equal data frame, everything works again. And I have to do a few other things in some packages, but there are very few packages that do that. We have a few packages that implement classes, that define classes that derive from capital D data frame. And so I changed those class definitions to have those classes now inheriting from DFrame, because DFrame is a replacement for data frame. So instead of inheriting from data frame, they should inherit from DFrame. And there's also an update object method. I forgot to mention it here in type, but at some point, so you can still run into a data frame instance, but the only way to run into a data frame instance if in a serialized object that was serialized, an object that was serialized before that change that I made in August. And so if you load that object in your session now, you're still gonna see a data frame instance. And at some point, data frame instances are going to be retired, right? They're going to become illegal. So, so there's an update object. The update object method is already implemented for vectors. So if you run update object on a data frame instance, it will turn it into a DFrame object. It's a very simple change. The internal representation of DFrame is what the internal representation of the old DataFrame class used to be. So there's no change in the internal representation. It's just a change of the class attribute. And that's all what the update method does. It changes the class attribute. At some point, the show method for DataFrame objects is going to issue a warning if the object being displayed is actually a DataFrame instance. And the warning will tell you to update that object. Right, so there are more things that need to be done to complete this migration. But for the first round of changes, I'm done basically, and I want to wait that we start the BioC, the next BioC develop cycle to do more on this. So not before the next release at the end of October. So yeah, that's it. Thank you.
So I guess I'll get started with the questions.
Sure.
So I don't know if you mentioned this, Hervé, but why have DFrame as a new name for DataFrame and not just have DFrame as the virtual class and just leave data like capital D DataFrame as the concrete class? Why do we have to do this sort of switcheroo?
Yeah, good question. And I actually considered doing what you're suggesting. I wouldn't have called it DFrame if that was the virtual class that we introduced to be on top of DataFrame and other on these DataFrame-like objects. I was thinking of calling it maybe virtual DataFrame, or I don't know exactly. I really consider that. It first seemed that maybe it was going to be easier. It's certainly, yeah, the big win by doing this is all the serialized DataFrame instances don't need to be updated. So that's really a big win because as you know, all serialized instances are always problematic. And I guess I didn't like the name. Well, we would have to. So what was the reason? I dropped the idea after it was late when I was trying to make the choice. Be going in that direction or doing what I did, and yeah, I felt that no, it was not. We would still have to change the class definition of the vector V uppercase class, right? The metadata column then should be virtual data frame, and same for summarized experiment, call data, raw data. There were still a lot of changes that would have been involved with it. So yeah.
Just a reminder to Hervé, you do have mentioned about the naming conventions about the genomic ranges and the G ranges.
Thanks for reminding me. We would have ended up. I like consistency. At all levels. In the code, in the naming of the classes. We have a very complex class hierarchy in the core infrastructure. With hundreds of classes, I think, and I spend a lot of time in that hierarchy, and sometimes I'm really, not happy with some naming inconsistencies. I have a hard time to remember what's this class about again, and I just realized, but it's very similar to this other one, and if the name had been, if we had chosen more systematic names, things would be much easier to understand. The code would be much easier to understand and to maintain. And introducing virtual data frame or DFrame on top of data frame would just break any naming convention that we've been using so far. Yeah, for example, so as Xian is saying, we have genomic ranges, which is virtual, and G-ranges is the canonical in-memory implementation for genomic ranges object. But the concept is genomic ranges, and that's a virtual class. And same with G-ranges list. We have genomic ranges list, the virtual class, and G-ranges list is the concrete subclass of that implements the canonical in-memory. And same with character list, etc., etc. So I really wanted to stick to that scheme, even if the cost of that is, having all those serialized data frame instances around that are going to become illegal at some point.
Well, wouldn't that argue for having SQL DFrame then?
It's not leaving the SQL data frame or DFrame aside. Just this two-class hierarchy, where you have a virtual data frame and below it data frame, or DFrame and below it data frame. I'm not happy with this one to start with. Not even bringing the SQL DFrame
but
into the picture.
Right, but if we're naming like.
Oh yeah.
If you then looked at the SQL, currently if it's called SQL data frame, right?
Yeah.
By your reasoning, it should be called SQL DFrame, right?
Oh yeah. Okay, yeah, I see what you mean. Yeah, sure.
You mean because it would be derived from DFrame?
Well, it's a realized instance of it, right? I thought that was the.
It's a complete subclass, and yeah, to put everything on the same. I can't control now I leave to the the authors of the other data frame complete subclasses to choose a name that they see fit, right? And but maybe you could argue that SQL DFrame would be a better name, just because it's a sibling of DFrame. It's just the SQL on disk version of it. Yeah, why not? Point.
And another question: how does this fit into the previous hierarchy of capital D, capital T data table?
Oh, and before I answer that, and you have to re-ask your question. Don't forget. And now I also chose to ignore the fact that data frame instances that are serialized, all data frame instances, are going to be problematic, because I still hope that we can do something about automatic updating of serialized objects when you call load or read RDS. And I've started to discuss this with Michael and Martin, and I think we all agree. And I remember discussing this in some of you guys, that it's really daunting that to think that we every time we're going to touch the class definition of our favorite class, we're going to break all those serialized instances, and it would be great if those serialized instances could be just updated automatically when you load them back in your session. So I've started with Michael, and he's that is a mechanism that will need to be implemented in R itself. Maybe adding some kind of hook to load or read RDS, and user defined hook, or we didn't discuss the details yet, but we agree that that would be good. And Michael and I want to start working on this for R3.7. So that's what we're going to start using. That's the current R development, and that's what we're going to start using for the next BioC development cycle. So maybe we have something like that really makes our life easier. Not in the not so distant future. Yeah, and you were saying something about data table. What is data table?
Well, if I looked at the data frame class hierarchy, right? There's this data capital D.
Yeah.
I don't know what that is, and I don't know what its concept
Yeah.
represents.
It's just so this is a virtual class with no slots, and the concept here is that it's just a rectangular thing. We could have called it rectangular, and that's it. No implementation. It doesn't assume so DataFrame is actually a subclass of data table, and the virtual DataFrame class in the future will remain a subclass of data table. So data table is even more, generic, and it doesn't. The big difference is that it doesn't make any assumption about along which direction how do you call this? The backbone of the object is running. If it's running vertically or horizontally. So concretely, it doesn't make any assumption about what the length is. Is the length the number of columns, like in a data frame, or the number of rows, like in a summarized experiment object? And or the length is just the number of elements in the rectangle, like for a matrix, right? So we have different rectangle objects that have chosen to define the length in different and incompatible ways. Data table stays away from that, so is then more generic. Yeah, it's just a trick to allow us to define some methods at the data table level and to avoid some code repetition.
So in your list of proposed additional, so there was SQL data frame and Parquet data frame. I didn't see RHDF5 data frame. Is that is it appropriate or something you would like help with?
I don't know. I don't know. I don't know. Maybe not. I mentioned I put Parquet because. But I've no idea if someone is working on something like that, or if we want to start something on working on something like that. Just I thought it looked nice to have more than two data frame concrete subclasses. And why not HJ5 baked data frame objects too, maybe.
And so maybe this is a question for the guys working on the SQL data frame, but what is the shape of the data in the background? Is it's still just one table, but in a database instead? Or I don't know enough about SQL to sort of guess.
Currently the SQL data frame has slot called table data. So this table data uses the lazy table read from the bplyr. So it doesn't inherit the simple list, like the list data structure as the previous capital DF data frame. So it doesn't meet the requirement of summarized experiment for the row data and column data. You have to be a capital DF data frame currently, but SQL data frame has like different flaws for saving the data, so it couldn't be fit into the summarized experiment right now. And that's why that's one reason we asked Hervé about this migration, the introduction of virtual.
Cool. In which case, if there are no more questions, that was an awesome talk. Thank you very much. I learned an awful lot from that, Hervé. And thank you everybody for coming along. Hope it's been useful. I'll put a summary somewhere in the Slack channel probably, and we'll arrange the date for next month as well. And I may well pick somebody like I did with Hervé, jumping on his email on the Devel forum to rope him into giving the presentation. So if you want to present, just send an email saying you're going to break everybody's packages, and I'll send you an invite. Thanks very much.
Thanks, Mike.
Bye, guys.